Hello, everybody, and welcome to our 12th Tour de Tools already. Tour de Tools is a series where where Gauthier and I are often joined by very interesting guests to discuss tools, frameworks, platforms, stuff like this. Gauthier, I'm going to leave it to you to introduce our guest of today.
Yeah. So the guest of the day is Moez Ali. So he's actually calling us from Toronto, Canada. At the time it is 9 a.m. So he's still drinking coffee. So a bit about Moez. So he was by profession a chartered accountant, and then he moved into different positions. Always a bit moving partly towards data science, to which he's now a manager at Moez. And in 2019, when he actually went back to school, he saw the need, and we'll probably learn more about that, to create PyCaret, which is the topic of the day. So welcome, Moez.
Thank you.
Happy to be on the show.
Thank you. Hey, I love the intro music part.
Thank you. We like it as well.
Yeah. Thank you. Thank you for having me here. How are you guys doing?
Good, and you?
Very good. Very good.
All right.
I'm very interested to hear from you. You're, I think, an avid open source fan and builder, creator of PyCaret, right, which by now has quite a bit of community behind it. Maybe you can start a bit by giving a high-level overview of what it is.
Yeah. So PyCaret is essentially it's an open source alternate low-code machine learning library in Python, written in Python. And the whole idea about this is if you analyze the talent pipeline of data science over last 10 years, you would see that people coming into data science, the 7-8 years ago, the percentage of people coming from quantitative background or a computer science background was very high. But post 2016, when these things have started to become viral, now you are getting all sort of people choosing data science as their as not their primary career, but like a secondary, which is your not secondary is the wrong word here, but as their second career, right? Which means that they have spent their life in finance, marketing, HR, supply chain, but now they are getting into this, which means that they are not coming from the same programming skill set like a computer scientist or a computer engineer would do, right? And in other words, Gartner has invented a term called citizen data scientist, which is data scientist who is citizen. And also there are so many citizen terms flying here and there. Like I've recently seen citizen developer. I don't know what citizen developer would do, but the idea when we started this in 2019 was same, that we should build a tool which is really simple to use. And when you are doing machine learning, the whole idea is you should be able to do one of three things. You should either improve the existing business processes in your company, right? There are manual processes. You do machine learning, deep learning, and automate it, improve the processes. Number two, you reduce the cost. Or number three, you increase the revenue, eventually increase the profit, right? If you're not doing one of this, you're just probably, it's not going to worth it at the end. So the idea, and people who can, easily target these categories are the people who are closest to business, which is the front line, and they are well connected to problems. The problem is they don't have the right skill set to do it by themselves. The tools we have today, they are created in the context of best programming practices, but the citizen data scientist is not the target audience for that. Yeah, you have alternate no-code tools, but not every company would buy them or can afford them, right? Because there are only few Googles and Microsoft of the world. 95% of the companies are not there yet, right? So the idea was to create a tool that allows data scientists or citizen data scientists to focus on the real problem, look at a big picture, why they are doing what they are doing, instead of troubleshooting Python code, right? So that was the idea. And the interesting thing was when this idea came to me, or when I started, getting serious about it, I was sitting in the first class of Python, like Python 101. workshop, and I had no idea what was Python. So I kind of learned Python and wrote this at the same time. It took me like 9 months to wrote the first version of PyCaret, and it was really good in terms of functionality and in terms of product.
So you were, in a sense, the target audience for PyCaret.
Exactly. I was like thinking, if I had to do something, if I had to solve a problem, I need a tool that allows me to iterate very quickly without any overheads. Okay, at least in the development phase. And the first version was very good. It was working the way it was supposed to work. But the problem was, because I'm not a computer engineer, the way I have written PyCaret was extremely difficult. Like, we wouldn't be able to scale from that point if we had continued that way. I had followed a complete functional programming structure, so no object-oriented programming. And I haven't used any of the cool things that Python is famous for, like decorators and stuff. And this guy called Anthony, who reached out to me 3 months after the first release, and he said, man, I'm a software engineer, not a data scientist, and I've reviewed the code base. You really need to change if you want to scale. And then he joined, and he started revamping the code base. And between April of 2020, when we did our first release, Anthony joined in June 2020, and today we are in August 2021. So it's almost like 16, 17 months. And we have done, today we have 2.3.3, which means in last 16 months, we were able to manage over 10 releases.
Okay, wow.
And PyCaret 1.0 was much simpler than what we have today. And over the period, our vision and kind of many things changed. So we have included MLOps functionality, and we are now talking about deep learning and stuff like that. So, and all this was made possible because of open source. I can almost give you in writing that if it was just me, I cannot build this. There are 55 contributors in last 15 months who contributed to this project. I cannot give an individual shout out to everybody, but it happened because of them. And today we have kind of a steering committee of 8 people, very diverse. 8 people from 6 different countries, 6 different time zones. So you can imagine it's already a hell for us to organize the time to meet, but we do meet every week. And each of this member in steering committee either is owning a module, which means they are writing or maintaining one particular module, or they are involved in overall governance process. And our goal is to make things a little bit more formal going forward. And that's only because there are so many cool open source projects around us. The challenge with open source project is it get traction for a little while, but it will die if you can't create a community around it. And when it will die, your all hard work will be wasted. So my goal right now, I mean, I started as a developer in PyCaret, but now I'm more into a leadership role where I'm just stitching things together. And my goal and my big picture goal is to actually create a team and community around it that can maintain it. And the point I feel satisfied about that, I can start, backing out a little bit into other ventures of my life. But right now, that's what I'm focused on, to build a team and community that can sustain the project. And, the community is very welcoming. I mean, it is, if you haven't worked in open source before, you won't be able to understand, but there are so many talented people out there all around the world. And everybody is willing to contribute. That's the great thing.
But it is impressive, like the community that is already there in a relatively short time. I mean, even if you didn't make the best code-wise product from the beginning, you clearly made something for which there was a need. I mean, it's shown by the community you already have now. It's impressive.
Yeah. I think anything that reduces human overhead inside the brain, I think people will receive it well.
Yeah, indeed.
All right. So I think you have some, as far as I understood, you have some slides and a demo for us. So
Yeah, so I'm not going to talk much about, on the PowerPoint. I'll just quickly skim through this, and then I'll, do a live demo. So a little bit about me, my background, as Gauthier mentioned, I'm a chartered accountant. I've spent first half of my career, like 6 or 7 years, in 3 different countries, which happen to be in 3 different continents. And my background is finance, economics, computer science, data science, which I have recently acquired when building PyCaret. But prior to that, I have worked for a healthcare or for a hospital in Pakistan, Tanzania, which is a country in East Africa, and I spent a little bit of time in Middle East, Dubai. In terms of industry, I've worked for healthcare, education, consulting, fintech, and in terms of my most or the only open source project that I have is PyCaret that we are talking about today. Some important links for, on PyCaret. All the notebooks or this presentation that I'm gonna cover today is uploaded on this this GitHub link, the last one, if you wish to download. So this is a high-level machine learning lifecycle. Starts with a business problem, then you source your data according to the business problem. You do some exploratory data analysis. You prepare your data, which means you look after missing values, impute them. You do scaling, you do feature engineering, you do feature selection, blah, blah, blah. There are 20 other things. And then you get into the phase where you split your data and then train multiple models, select a metric to finalize one model. You select that model and then you deploy it and monitor it, right? That's the overall life cycle. And this happens in iteration. I mean, you define your business problem once, but from this part here, data sourcing to deployment, you would be really lucky if you just perform one experiment, get one model out of it, and you deploy it. That would be very lucky. You have to do iteration like anything, and it takes a lot of time. You have to iterate not only just for models. The reason that the loop is here, covering the entire box and not just the model training, is there are 2 kinds of iteration. You can iterate through your model. You can try XGBoost, Light, GBM, Random Forest. You can tune their hyperparameters. You can tune their weights, but you also have to iterate in terms of data, right? So it's a big, giant iteration loop. Now, this may look simple here, but if you break down this data preparation stage, right, it looks something like this. You have data, you do train, test, split, then you take your train set, you apply missing value imputation, feature scaling, encodings, feature engineering, blah, 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 10,000 different things. And then you finally prepare your data and you set up a cross-validation environment where you have to set a very reliable cross-validation environment in which you train multiple models and you take one or few candidate models out of that environment, you ensemble them or whatever you want to do, and then you eventually deploy it, right? So this is a very iterative and complicated process. So there's a one giant iteration loop, which iterates from data to modeling. Then there's iteration loop in the cross-validation where you try different models. But also there is the iteration loop of pipeline. You want to do one hot encoding and then train multiple models, and then you want to do target encoding and see if that changes things, right? So you're not only iterating data, you are now iterating pipeline, and inside pipeline, you're iterating models. So three loops going on together. We have a question?
No. It's just us reminding people that they can ask questions if they want to.
All right. So the challenge is, as we talked, it's a very iterative process and very time consuming, right? And right tool in the hands of right people is very important, as we talked in the beginning. And finally, creating a pipeline, which is steps orchestrated in a sequence, is hard, but running that in production or managing it in production is hard. But thanks to a lot of open source tools today, that makes it so easy for us to do, right? And what we did at PyCaret is we just stitched great open source projects together, which is amazing. So finally, this brings me to what is PyCaret. So it's an open source low code machine learning library. That's what it started as. And now we say it's an end-to-end model management tool that you can use to automate your machine learning workflows, right? And we'll see that why I'm calling it model management too. Our claim to fame is it's easy to use, it's a productivity tool, and it's business ready. These are the things that you can do in PyCaret. You can prepare your data, which means all kind of pre-processing. There are 25, 30 different options. You can train your models. You can automatically tune their hyperparameters using different frameworks. You can analyze and interpret your trained models. And you can do model selection. Model selection is a byproduct of all this. The reason you are doing this is so that you can select a model. And experiment logging is an MLOps piece where everything that you do is logged automatically in an MLOps system, where you can just click a button, deploy it on cloud, locally, all the bells and whistles that come with any MLOps system. We have a couple of use case support. For supervised machine learning, we have a classification module, a regression module, and for unsupervised machine learning, we have four different modules. And one module which is currently in the development, we have an alpha release for time series, which is a separate module for time series that combines both the statistical methods as well as like ARIMA, SARIMA, all that, as well as classical regression models. And it is built on top of, again, many other open source projects, primary one being skTime. And this is the impact graph that we kind of created when we were releasing PyCaret. So what you're looking at on x-axis is the different stages of machine learning. So we kind of break them down in 4 stages, and y-axis is cumulative lines of code. And what we did, we designed an experiment where we have, let's say we had 10 tasks, and we picked person A and gave those 10 tasks with same outcome required and give it to person B. Person A was using scikit-learn and person B was using PyCaret. And by the time they finished the experiment with the same outcome, the one who was using scikit-learn had written 160 lines, and the person who had written used PyCaret had written only 20 lines to achieve the same outcome. Now that doesn't make PyCaret better than scikit-learn, because under the hood we are also using scikit-learn, right? But PyCaret is abstracting that complexity if you choose not to write that lower level code by yourself, right? There may be merits in writing directly lower level libraries yourself, but depending on the use case, I think most people in the experimentation phase wouldn't care about writing 50 line of code themselves.
No, and I think also out of my own experience, for example, because we mentioned scikit-learn here, a lot of the times you do the same stuff, and it's not exactly, but a lot of the code is a bit copy-pasted, because you're trying in the end to set up the same type of experiments to say, and even though some parameters are different, a lot of it is copy-paste.
Yeah, exactly. So this is another thing, right? I mean, if you don't use PyCaret or any equivalent library to kind of reduce that overhead for yourself, you will find yourself copying paste your own boilerplate code every time, which is kind of inefficient, right?
Quick question, like, oh, sorry.
Go ahead.
Like because I assume there is kind of a trade-off between like the fact that you get something higher level and that you can also tweak the little things, right? I mean, I assume that in scikit-learn you can go and do little things. Like, how do they maybe integrate? Can you because you use scikit-learn, can you, for example, say at some point, yeah, well, I don't know, like this model selection, for example, I would really like to implement my own stuff. Can you easily get back?
Yeah. So there's always a trade-off. When you abstract something, you lose a little bit of flexibility. What we try to do is we try to cover it by providing as much custom options. So if you have your own custom transformation, you can pass that. If you have your own mathematical model, you can create an object out of it. And if it's consistent with .fit and .predict API, PyCaret can accept that. If you have, any custom column transformation, you can do that. So we try to provide a lot of custom options. But in our experience, like if I have to make a product or a company out of this, okay, I would say I would not focus on that area, even though the options are there, because in our experience, less than 1% people are using them. 99% of the people, which is, you can imagine 99% of 800,000 people, which is a big number, they use out of the box functionality. So we appreciate there are complex use cases, but to be honest, that's very less in number.
I think this is also a bit, of course, like this is the audience you're targeting with a low-code system. That's a bit the Pareto principle. You're like 80% of the models that you're building are probably relatively simple, straightforward, for which you have a solution with PyCaret. The other 20% is going to be more complex, and PyCaret will probably at some point reach its limits there.
Yeah, exactly. But now, I mean, we'll see when we get to the demo part. I will try to show the flexibilities there. And we started with a kind of a very simple idea that it would help you, in your normal data science experiments. But we have reached to a point in last 12 months. You see, now you can use PyCaret on GPU as well. So you can see that kind of allows you to do machine learning on scale. And as we are talking today, we are building a backend compatibility with Dask and Ray, which means now you'd be able to perform the experiment on 500 million records using the same exact code, which kind of makes it really powerful. Imagine you're using the same exact code, exactly same thing for a very small experiment, for a big experiment that you can distribute on GPU, or for a very big experiment where you need cluster and each cluster would have GPU. And again, all that was made possible by a lot of other open source projects under the hood. Some cool numbers, I always brag about them. The number that I'm most proud of is this 55 contributors. Really grateful to them, and they made it possible for us to get to this point. These are the integrations and bells and whistles that are going under the hood. So you see, we use scikit-learn for our CPU trainings. We have Rapids. Rapids have two wonderful projects, CUML, CUDA, that we use for GPU. Ray we use for distributed hyperparameter tuning, distributed computing. MLflow is our MLOps piece here. Optuna is training. Plotly Yellowbrick is plotting functionalities. So and there are a few other dependencies, integrations as well. So all these cool open source projects made it possible. So a big shout out to them. And in terms of our roadmap, now what we are looking at is, so PyCaret, if you have used PyCaret before, it's a functional way of programming similar to R. You just import the functions and do your work. What you get back is a scikit-learn light XGBoost object, which is a class that you can use for inference or prediction. But when you are writing code in PyCaret, it's a functional code. Now, what we are doing now is, without changing our functional API, because that's the thing that got us here, we are adding a new API support, which runs parallel to that, which will be an object-oriented API, which is a more formal way of doing coding in Python. That's how all the other libraries are built. So we are adding that object-oriented API support for 3.0. We are rewriting our pre-processing pipeline. So it's a very big project that we have undertaken. And the reason we are doing that is so to become 100% compatible with scikit-learn. Right now, we have few functionalities that we have homegrown. We have built it ourselves. And what we are doing now is we are taking those functionalities and pushing it back to the libraries where they belong, skTime, sklearn, wherever they should. Our goal is to become a major abstractor. Our goal is not to write our own algorithms. And the reason I want to do that, or we want to do that, is so that we don't want you to have PyCaret in runtime. It's not needed. PyCaret is an experiment design tool. Use it on your cluster, your local computer, wherever you want. But once you check out your pipeline from that as a pickle file, as an Onyx file, as a whatever file you want, and we'll have a couple of options, you just take that file and deploy it. You don't need PyCaret and all the bells and whistles in runtime. If your final pipeline is a scikit-learn pipeline, you just need scikit-learn in runtime. If your final pipeline is an XGBoost pipeline, you just need XGBoost in runtime, right? So that's where we are trying to go.
It's cool. There's a nice separation of concerns there.
Yeah, like this as well. So does that also mean that because you talked a bit about MLOps, which I understood that so far being really the experiment tracking. So it means you completely leave out the deployment part. Like you said, this is kind of, let's say, not our concern, like up to you to do what you feel is the best thing.
Yeah, so the MLOps piece will stay only in the context of experiment design. So when you are performing an experiment, you are training 10,000 models and you have 10 metrics for each model and 100 hyperparameters. How do you log it, right? So That's the MLOps piece, although I don't know if that would be the right word to call MLOps, but I think it is operations. That piece stays within the PyCaret. But if you're talking about functionalities, data drift, concept drift, whatever, that kind of post-production thing, you kind of manage it at your end.
Okay.
And then we have support for parallelization coming up, and that's what I'm really excited about. And then we have a few new modules like deep learning recommender systems that we are building. And the timeline for 2.0 is roughly, I would say, next 5 to 6 months. We'll do a couple of alpha releases for that before we make a final stable release, but I think it would take another 6 months to finish this. Okay, that brings us to the demo part. I'm gonna head over to my Jupyter notebook and open up a new notebook. So this code here from version, I'm just checking version. This is the most recent stable release, 2.3.3. And then I'm just going to import a toy dataset from PyCaret repository. So let's just say get data is equal to get data. Let's just say use. So this is a classification problem. Each row here is a transaction. It's a pretty small toy dataset, and we have to predict whether the customer buy CH or MM. So these are two different kind of juices, and based on the attributes, you have to predict that. So 1,000 transactions and 19 comments, right? So this is the data set we will be working with. Because this is a classification problem, we have to import from PyCaret.classification, import star, and this would actually import everything that you would need for experiment, right? So that's why I was saying this is a very functional way of writing code in PyCaret. The first step is you initialize the setup function, and now this code is common across all modules, whether you're doing classification, regression, clustering anomaly. This script stays exact same, which means that it is so small and simple that you will feel lazy to open another notebook and copy the code. You would say, why don't I just write a code again?
Okay.
Setup takes two mandatory parameters. It takes data and it takes target variable name, which is purchase. Okay, that's it. And you run the setup function. It would go behind the scene, infer the data type. So you can see it picked up ID column automatically. It would do that, and it would ask you if these are all correct, type enter, otherwise quit. I'm going to assume they are correct, so I'm going to press enter, but there are ways to override the data types or maybe silent this verbose if you want, if you're using Python scripts. But if you see the documentation of this function, there are all the bells and whistles that you can handle. It does three things automatically. So it would, if there are missing values, it will clean them, it will impute them, and there are different methods. By default, it would use simple imputer, but you can change it to iterative imputer, and that's our original implementation that Anthony wrote. It's basically the same thing as mice in R. Yep. If you've heard that. So it would impute missing values. If you have categorical features, it will encode them because most of the algorithms wouldn't work with objects or strings. And then the third thing it does is if you have, in this case, you see our label was string. So it did a target encoding, converted CH and MM to 0 and 1, right? So if you had 7 target variables, it would have encoded them. If your target variable is already an integer, it won't do anything. But if it's a string, it would do the target encoding as well. Okay. But anything other than that, you just have to pass true and false flag. So if, let's say, you want to normalize the data, you can just say normalize is equal to true. And then you have all the different methods of normalization like min, max, z-score, quantile. You can just pass them as a string, and behind the scene, we would get it from scikit-learn or wherever it is applicable, right? You have all the common transformations like U-Johnson transformations. You can do PCN stuff. You can bin numeric features. You can remove outliers, multi-collinearity. You can create automatic features, and a lot of it, right? And this is where that custom thing. So if you have your own transformation, you just pass that in a custom pipeline, and we take that into account.
And the custom pipeline is a sklearn pipeline.
It would be a sklearn pipeline.
Okay, clear. Yeah. And if you let's say the normalize option, one of these options, like are they applied to the whole data set, or can you define also columns?
Right now, it would. So if you do normalize, the logic is all the numeric features would be normalized.
Okay. And if you want to, let's say, create, let's say, a derivation, new columns, let's something like something like that, or a lag features, these you would add this via a custom pipeline.
Yeah, I mean, like for polynomial trigonometric features, there are options here. Like you can just set it to true. But let's say if you want to create something really custom, column A multiplied by B divided by column C multiplied by 1.3, then you create a custom object and pass it in custom pipeline, right? and there's all sort of things. What I'm going to do now is I'm going to turn off this field here. So you see, once you run the setup, this would basically print this grid, which contains a lot of useful information in terms of cross-validation environment, pre-processing, number of CPU jobs. But if you want to run the exact same code on GPU, all you have to do is say use GPU is equal to true. And now if you run this code, hopefully, and if it finds GPU on your computer, okay, if it finds GPU, it would switch all the processes. It will, all the CPU processes will fall back to GPU wherever applicable.
Nice.
And see, use GPU true. I'm not gonna use GPU, so I'm gonna remove this. One field I want to use this here, log experiment is equal to true and experiment name is equal to, let's say, ABC. Okay, and we'll see what it does. And I will also just say log plot. Actually, let's do that. I'm going to run that again.
Yeah,
and now,
while you launch this, we have a small question from Vitali, which is asking, are you planning, oh wait, oops, I'm showing are you planning to implement a computer vision model?
Not yet. Not yet. So our target audience is, it's more on a tabular time series NLP kind of stuff. We haven't received a lot of interest in computer vision module.
Okay.
Okay. So I have started the setup, passed the data, target, and these variables, which I'm basically telling PyCaret to log everything. Okay. Now, the first function that you would usually do in PyCaret is this function here. Compare models, which is our flagship function. And one more thing PyCaret does at this point is takes the original data set and it does the train test split. So it has, at this point, we have a train set and a test set, which is transformed, right? When you run this compare models function, what PyCaret would do behind the scene, it would take all the models that it has in Model Zoo, like a AutoML does, and it would train them using cross-validation, whatever cross-validation is defined. By default, we are set to stratified k-fold using 10-fold. You can change the number of folds. So using cross-validation, it's going to train multiple models, and it is going to evaluate these common metrics. You can add or remove metrics. There are functions to do that. But at this point, what I see is a table, a list of models trained on train set using cross-validation and their metrics, right? And you know, it's kind of interactive. As you're running it in Notebook, you would see the progress and everything. But basically, this function will return you one best model based on the metric that you define. By default, is set to accuracy. And we are using 10-fold cross-validation. You can change it to any different time series cross-validation or even your own custom cross-validation if you want to write your custom cross-validation. But the idea here is with this one line, you get a lot of models here. And you know, at this point, your best model based on accuracy is rich. Now, if you are writing, let's say if you have a very big data set, what you can also do is create a loop, put it in user-defined function and distribute in PySpark. You can do that, right? You can do a custom distribution, like you can distribute custom functions in PySpark or Dask or Ray. So if you want, you can do that.
And that means you can also have custom metrics. Like if none of these are relevant for your problem, you can create your own performance metric.
Exactly. So if you want, you can basically, there is a function called add metric. And if you check the documentation, you can either just, create your own metric and pass it, or you can, let's say you want to use something else which is not here, but it's in scikit-learn. You can just import it from scikit-learn and pass it.
Okay.
Right. While compare models, and this at the end of the day, this returns you model, right? Which is basically, if you see this is a rich classifier, and we don't want to reinvent the wheel. This is a scikit-learn model. If you can work with scikit-learn, you can basically call any attribute from this, right? That's why I was saying we return object, but the way you write code is not object-oriented. You just call functions from PyCaret.
So that's a native sklearn object that you get back.
Yeah, it's a native sklearn object. If you want to check intercepts. If you want to call predict on this, you call predict on this. It doesn't matter, right? We could have abstracted it in PyCaret's class, but then our goal is to not have PyCaret at runtime, right? That's the whole idea. Now at this point, you have one final model here. You can include, exclude things. While compare models is really cool, the function underneath that kind of sticks all this together is called create model. So the way create model works is you just say create model and LR, and it takes a string of estimator, right? And LR is short form for logistic regression. And now let's just say fold is equal to 3. Okay. So you see I have a 3-fold cross-validated logistic regression with all these metrics, their mean and standard deviation. Now, if I haven't defined a fold, let's say just go with decision tree 10-fold, the mean score here is same as what you see in compare model. So if you see decision tree 76% in accuracy or 76%, 7669 in AUC, this number would match, right? Because compare model is just an abstraction of create model. Now now at this point, you know that you can do this, which also means you can do this, something like this. My models, you can create a list comprehension like this. Create model I for I in DT, LR, light DT, right? You can write this list comprehension that can train these 3 models, but you don't need to hard code these 3 models. What you can do is do it dynamically. You can do something like this. Best compare models and select is equal to 3, which means give me 3 best models, right? Mm-hmm. And then based on, like, every time you run this command and you have a new data set, those 3 models are dynamically selected, right? And then you can use this variable to do any kind of list comprehension. Now, this is a very basic example. Probably you won't do it this way, but the way you would do it, now my models has 3 models. Now, I have hard-coded them, but you would select them using compare models.
Right.
There's a function called tune model. So if we just see DT, our base decision tree is doing 7669 in AUC. There's a function called tune model. So tune model, it takes decision tree as only mandatory parameter. When you do that, we are gonna go behind the scene, dynamically generate the search space for a particular algorithm, and then we're gonna iterate over using random grid search. So in this case, just using random grid search, we increased AUC quite a bit. But the real power here is now that you know that if you can do that, which means you can do something like this. My tune model is equal to tune underscore model I for I in compare models and select is equal to 3. Right? So this is like,
it's nice.
Your loop would run first, and then what you get at the end of the day is those top three candidate models being tuned. And if sometimes during tuning, your results may not improve. So there's a parameter called choose better, which means that if you say this, what it will do is it would first get the 3 candidate models, tune them. And if tuning doesn't improve the result, it would still return you a base model. Okay? So you can.
Oh, sorry.
So this one command, like if you want to create your own auto ML system, you can literally have this command here, one line, which would dynamically do all the steps. Obviously, you have to run setup command as well, right? But after that, you can have this. And not only this, what you can also do, similarly, we have, see, I'm again creating decision tree again and again, just because I'm too lazy to scroll up. And it is so simple, I'm doing it. You should probably not do that. But there's a function called ensemble DT, which can ensemble your models. So if I just do that, 76% after ensembling go to 85%. And what is ensemble? It's a bagging classifier from scikit-learn, which is wrapping your decision tree, which also means that at this point, not only this, you can also do this ensemble model, and you can wrap it. You can stitch everything together, right? I'm not going to run it. It would take some time. But if you want, you can do this. So it would now run the compare models, select 3 candidate models. It would tune them, and then it would ensemble them.
What I like very much of this is that the grammar is very intuitive. Like if you this line, you know more or less what is happening.
Mm-hmm. Readability is very, 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 very good here.
And I assume, because to me, like the tuning here, of course, like it's a test data set. Tuning typically, especially with real life data sets, can take a long time. I assume that you can parameterize a bit like the min max bounds that it goes through in this random.
Yeah, very, very good question. So we have our decision tree. So let's see the tuning. So the good thing, or the bigger thing in tuning here, you know how there are various methods to tune, right? There is a random grid search from scikit-learn. There's complete grid search, which normally you can't use in real life because complete grid search may take months to complete. But there's also Bayesian frameworks. There's Optuna. There's TPE methods, and every library has a different API. What PyCaret did is it kind of combined everything together. So now that if you want to tune your decision tree not using scikit-learn search library, what you want to do is use Optuna. Now this is gonna, if you have Optuna installed as a dependency, what it would do is it would use the same search space, but this time it's using Bayesian method to get to the best hyperparameters. In this case, it didn't improve the result. The random grid search was better. But the point is, there are different methods that you can use. And we have scikit optimize. You can use TuneSklearn. You can use TuneSklearn is a project by Ray. So if you use TuneSklearn, you can actually, in real life, if you have a very big search space, you can distribute it on Ray cluster. Right? That is one way. And to your point, if you want to just cap your min and max parameter, you can go as far as passing a custom grid here, which basically you can just pass your own search space, right? The way I use sometimes, if I really want to focus on one hyperparameter, now that you know that you can, it's really flexible. Let's just talk about light GBM. Do we have light GBM? No. Let's just create light GBM. So what if you want to change one of the hyperparameter of light GBM, right? Well, what should you do? Well, there is no option.
I just put a question on the screen. It's actually a question we just got from Hamide Iraji. I'm not sure if I can pronounce it correctly, but the question is, how can users pass model-specific parameters?
Yeah, I can read minds as well.
and we have another question afterwards, also from Hamid.
So you see, we have this light GBM. The default parameters are what they are in the default library. So in this case, learning rate is equal to 0.1. But if you want to create a light GBM with learning rate 0.2, just pass learning rate 0.2. And this time, this light GBM, if you may see, this is 0.2. Now, combining this knowledge from our previous knowledge, you can also do something like this. If you want, import NumPy as NP, LGBs. You can create a list comprehension like this, create model, light GBM, learning rate is equal to I, right? For I in np.range, 0.1 to 0.9, 0.1. And just so that it's fast, I'm just going to say 4 is equal to 3. So this is now iterating over those 10 combinations, right? And it is creating multiple light GBM with different, and I'll show you the reason why I did this here, right? Because you won't remember all these numbers, but remember we have that log_experiment true. Okay? So now what is happening behind the scene, everything that we have done here or doing, whether it's plotting, sorry, we haven't done any plot yet, but whether it's training, tuning, ensembling, or anything that you're trying, everything is being logged. Okay, so now this light GBM should be a list of 10 different light GBM classifier. Let's just quickly see a few other things. So if you wanna let's just create another light GBM, LGB, create model LG light GBM, a simple default light GBM. There is a function called plot model, which just allows you to, again, just like all the other things, you just give us the string and we would generate the plot for you. So this is AUC plot. This is, you can just say confusion matrix. You can just say, so very quickly, I mean, you can imagine you can do things like this. Plot model, we have created this light GBMs, right? LGBS 0. And you can do LGBS 9, which is your different, sorry, not 9, 6. So you see the difference between, you can immediately see the difference between different variants of your model, right? Now, if you're very lazy to use plot model, you can just pass your model into evaluate function and you see this lights interface. You can, it's the same thing as calling plot model individually, but basically you have AUC plot, you have confusion matrix, you have class report, lift chart, gain chart. You have things like decision boundary, which is, if you have to do it yourself, you have to, write quite a line of code. You can do feature importance, KS statistics, blah, 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 right? A lot of options here. In terms of interpretability, we have integration with SHAP, which means that you can, under the hood, you can also interpret your complex tree-based models or neural networks, MLPs, that if you're using that. And it would generate that BSWAM plot from SHAP library. But again, this function, if you check the documentation, has, again, in terms of interpretation, it has SHAP, it has PDP box, it has few other implementations that you can use, and you can just pass it as a parameter, and it would use that.
And where do you, because we were going over the experiment results, the logs, where do you store these? Do you export these so that you can restore them for future?
Right now, because we are using MLflow, right? So if you are, so this is your SHAP plot. So right now, what it is doing behind the scene is it has created a folder here in your local environment. Let me just raise
But it's just it's the native MLflow implementation, basically.
Yeah, it's a native MLflow, but the way you would actually use it here, ML runs. So it is storing everything as a file here, right? All these are runs, parameters, metrics, if you see. But the way you would use it in production is there are two things you have to do. For you have to pass a relational database, and then for your artifacts you have to pass a AWS S3 bucket or something like that, right? So when you're using it in production in your teams, you would actually configure that, and you can do that before running the setup. You just run that one line from MLflow, and it would talk with PyCaret smoothly. The last thing before I show the logging, all the work that we have done so far, is
I know that you have a hard stop. It's just to alert you that it's almost 10 to.
Yeah, I got it. And the last functionality is you can actually now, if you see, you can save this, right? So I'm just gonna save my LGB and name it ABC. You see, this is a pipeline. This is not a model. So everything that we did in pre-processing, everything is stitched together here. So from sklearn.utils, let me just make it a little bit better. Import set config, and I'm gonna say set config is equal to set config is equal to, what's the parameter? Display is equal to diagram. Okay, and now I'm gonna load this pipeline using load model ABC, and if I show you visually, this is what it looks like. Okay, so all these simple imputers, blah blah blah, all these steps, and this is our final light GBM classifier. Right now, at this point, if you want, you can just deploy this. Deploy model LGB, and you can say platform is equal to AWS. Authentication dictionary, it takes name of bucket because it's AWS. And model name, let's just say model name is equal to ABC AWS. This code here would take your pipeline and deploy it on AWS. Now you can call this pipeline from AWS and just call the predict function of it.
Where did you deploy this? Like, what are the
in a S3 bucket?
Okay,
as a file, not as an API, as a file.
Okay,
Right?
and then that means that you can there pick it up with whatever service you like,
Yeah.
either use something you custom or SageMaker or.
Exactly. You got the point. Now the last thing is you want to see all that you have done here. You just say MLflow UI, and it will initiate a server. Because we are on local machine, it would initiate on localhost 5000, and you would see a very cool. If this works, you will see a UI. It might take a little bit of time, but you will see a MLflow UI. Okay, there you go. Yep. You'll see MLflow UI. You will see your experiment here, and in the experiment, you would see. So you see all these are here the individual runs, model train, and if you click on one of them, you would see their hyperparameters. You would see their metrics, the same that you were seeing in the notebook. You would see a few other information, and then you would actually get the pipeline. You just copy this code. This is from MLflow. This is exactly how you would call the inference on this. If you want to use MLflow functionality, you would see conda file that we automatically created. You only need PyCaret 2.3.3. We have a pickle file, which is sitting in this location. In production, it would sit on a S3 bucket or Azure something. You have a requirement file, and then you have plots that we have logged, and all that is logged. Right now, MLflow has some cool native functionality. If you want, you can do something like this, right? Remember, we created a loop over light GBM. You can just select those light GBMs with different learning rates, and just say compare, and you can just compare their learning rate and AUC. You can do things like that, right? With MLflow native functionalities.
Nice. And is there a way to, you just deployed something to S3? Is there a way, the one that you deployed, to link this back to the right experiment?
So if you, you can create a custom tag. So in this, you can just say, if you want to finalize something, you can come here and just say, let's say you want to, you can add a tag for your MLOps team to pick a right model from here, or you can actually also add nodes for your MLOps team, right? And they would have the access to the same thing, and they would come here and take it from here. Normally, you would either use, for deployment, you would either, if your full stack is on something like Databricks and you are using Databricks, you're not use AWS, right? Because you would basically just use the native functionalities of MLflow, which is, when you come here, you can click on register model. So this register model would now serve it as an API endpoint. So you would do one of the other, right?
Exactly. Yeah, see what you mean.
All right. I am a little bit over time here, but I really enjoyed. If there are any questions I can answer.
Maybe there's a final one. It's about Optuna. Which Optuna tuning do you implement?
Which Optuna tuning do we implement?
I assume that there are multiple types in Optuna library. I'm
yeah,
familiar with Optuna myself.
So a couple of them. So in the search, there are two things, right? There is a search library and there is a search algorithm. For search algorithm, you have multiple options, and I think we have covered quite a few of them. If you're using Optuna, you can either use their random search or you can also use their TPE search. So these two options are.
Okay. Yeah. Cool. Thanks a lot. It was
a
super interesting, super interesting framework. I'm looking forward to testing it out myself.
Great. Thank you so much, guys. I enjoyed it, and all the best.
Thank you.
Thank you.
Bye, boys.
Bye.